I think that this PhD program, as far as I can understand it, is on psychometrics. And I'm not an expert in psychometrics. You have received experts in psychometrics like Hambleton and so on. But I would like tonight, to discuss one nice application of multidimensional within item scaling. And this is a research that I'm conducting right now. And it's not yet finalized, it's not yet published, but I hope that in a few months it will be published. So I would like to discuss with you the scaling of OTL measure in international survey in education. OTL stands for opportunity to learn. First of all, I don't know if everybody here in the room has a background in education, especially in international survey in education. And there is nowadays mainly two institutions, international institutions, that can conduct international survey in education. The first one, the IEA, stands for International Association for the Evaluation of Educational Achievement, was created at the beginning of the 60s, and you will see that up to now they have conducted about 40-50 international survey in education. And more recently, at the end of the 19th, the OECD, Organization for Economical and Cooperation Development, came on this international survey market with the famous PISA study. You must also know that the OECD is also conducting the TALIS study, which is a teacher survey in secondary school, and is also conducted right now the PIAC study, which is a survey for adult literacy. And at the beginning of the 80s, this survey was called International Adult Literacy Study, and now it's called PIAC. This table presents you all the international survey that has been conducted between the beginning of the 60s up to the end of 2000. And you can see that in black, this is the international survey conducted by the IEA, and in blue you have the international survey conducted by the OECD. And then you have the 60s, the 70s, the 80s, the 90s, and the 2000s. And you can see that most of the international survey in education concern mathematics education, science education, or native language or language of teaching, mainly reading and literacy. This table is quite interesting because you can see that since the beginning of 2000, there is an explosion of potential international survey in education to which each country can participate. That's the first thing. The second thing that appeared at the beginning of the 2000s is nowadays all these international survey in education are designed to compute trends indicators. So in the methodology, everything is set up so that we can compute with some accuracy trends indicator to follow the performance of the student and the educational system. And for instance, in 2001, PIRLS mean was Primary International Reading Literacy Study. And for 2006, they changed the name, and now it's Progress International Reading Literacy Study. The TIMSS study, the first one, it was in '95, and it was the first international survey in education where students were assessed in more than one domain, stand for Third International Mathematics and Science Study. And nowadays, TIMSS mean Trans International Mathematics and Science Study. So all these international survey in education are designed to compute trends in performance. Now, let's move to the topic of this talk. I would like to talk about opportunity to learn. This international survey in education, well, first they want to estimate the student distribution in reading, mathematics, or in science. but they are also designed to identify country factor, school factor, teacher factor, and student factor that can explain why some countries are highly performing and some other countries are low performing country, why some schools are highly performing, why some other has a low performance, and also why there is higher achiever and low achiever at the student level. So many background information is collected at the student level, at the teacher level, at the school level, at the country level to explain performance differences. And the first international report was written by Hussein on the first international mathematics study. The data collection was in 1965, and the international report was in 1967. And in this report, you can read, one of the factors which may influence score on achievement examination is whether or not students have had an opportunity to study a particular topic or learn how to solve a particular type of problem presented by the test. So, for this first international study, they ask all the teachers of students that participate in the study to fill in the test, not answering the test, but the teacher for each item was asked to rate the test item according to three possibilities: A, all or most of at least 75% of this group of students have had an opportunity to learn this type of problem; B, some between 25 and 75 of this group, blah, 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 and C, few or none, that's under 25%. Any responses A was scored 87.5. Any response B was rated 50. That's the middle of between 25 and 75. 87.5 is the middle between 75 and 100. And C was rated 12.5. What are the results that were observed in 1965? Here, this is an extract of the international report written by Hussein. You have the country that participate in the first international study in mathematics. You have the average rating for the test by the teacher, and you have the performance. The first international mathematics study consisted of 4 populations. Population E1 consisted of all 13 years old. Population 1B consisted of the grade attended by most of the 13 years old. And 3A and 3B consist of all students in the last grade of secondary education, just before higher education, tertiary education. And 3 consists of specialized students in mathematics and students not specialized in mathematics. And you can see that at the country level, you have a correlation of 0.64, 0.73, 0.80, and 0.40 between rating of opportunity to learn and performance. So the more the teacher rate as known the item of the test, the better the student is. Now, you can see that here, this is also from the same report. You have exactly the 4 population, but you have the correlation at the country level, within country. So, for instance, for population 1A, England and Scotland get a correlation of 0.56 between OTL measure and performance. And you can see for 1B we have more or less the same, a high correlation. And you can see that in some correlation, you have 0 correlation. So in some country, the measure of OTL is working properly as expected, and in some other country, it's not working. Maybe there are different reasons why in some country the measure of OTL is not working, especially in some Scandinavian country, because in some Scandinavian country there is nearly no between school differences in performance, and therefore it's quite difficult to find a school factor that highly correlates with the school average, as the school average nearly do not differ from one school to another school. For the first international science study that was part of the 6-subject survey, we also measure the OTL, opportunity to learn, and once again, the science teacher has to rate each test item, but according to a 5-level category. All students will score as 4, be more than 75 of the student will score than 3, between 75 and 25 and 75 will score as 2, less than 25 was 1, and none of the students will score 0. And they compute OTL mean at the school level and the country level, and in the report you can find correlation at the country level and the school level and at the student level. And in the first international science study, 3 populations were tested: 10 years old primary education, 14 years old lower secondary education, and last grade of secondary education. And here you have the correlation at the country level. You can see that in primary education there is no correlation at the country level. But you can see that there are not many countries participating in this survey. You can see that at lower secondary there is a regression line, and you can see that as the OTL average increase, the science performance is increased as well. So you have quite high correlation at the country level for lower secondary educational system. For the last grade of secondary education, John Keeves and Comber decided to represent 2 regression lines. You have this one and you have this one. And they did represent the second one because this is England, Scotland, Australia, and New Zealand, 4 Commonwealth countries. But you can see that at the end of secondary education, there is also a relationship between opportunity to learn and science education performance. Now you can see that you have here the average, the minimum, maximum correlation at the school level within country and at the student level within country. And you can see that at the school level, you have a correlation average of 0.20 for population 2 and 0.40 for population 4 at the end of the secondary education. And you can see that at the student level, on average, you have nearly no correlation between opportunity to learn and student performance. You also have a measure of OTL for the second international science study and also for the second international mathematics study. And it was the international science study was conducted by Neville Postlethwaite from Hamburg. I don't know if you have ever heard about Neville Postlethwaite. And in the report, you can see that the measure of OTL has a low to moderate relationship with achievement within country. It can be argued that if the measure of OTL has been more accurate than a stronger relationship between OTL and achievement would have been found. So Neville Postlethwaite say, well, we don't have big correlation, but it must be mainly a measurement problem. At the between country level, there is a stronger relationship between OTL and achievement. And in the second international mathematics study, they did measure the opportunity to learn, but they just analyzed the relationship between OTL and the percentage of correct answer for each item. So they didn't never compute the correlation between performance and OTL. Now, let's move quickly to the third international mathematics study. In the third international mathematics study, a very detailed mathematical framework was designed, and it was 10 main categories: number, measurement, geometry, position, visualization and shape, geometry, symmetry, and so on and so on. And then you have subcategory and sub-subcategory. And the OTL measure was as follows. So you have all this framework, mathematical framework, and the teacher, in the teacher questionnaire, has to answer how long did you spend teaching each of these topics to your mathematics class this year? Will you cover any of these topics in future periods? And you have F12 this year's, 1 to 5 periods, 6 to 10, 11 to 15, more than 15. Will teach later this year's, not taught this year's, taught a previous year's. People working at the IE Data Processing Center in Hamburg spend hours trying to find a relationship between OTL and performance in TIMSS, and they never found any relationship. So this OTL measure in TIMSS didn't work. Now, let's move to PISA. I guess everybody has heard about PISA. You know that PISA congratulates Poland because Poland's performance is increasing. So Andrea Schleicher, who is responsible of PISA at the OECD level, always used Poland as an example. So you can be proud of your educational reform that has increased the efficiency of the educational system as well as increased the equity of the educational system. But in PISA, you know maybe the sample design of PISA. We select school, and within school, we select 15 years old across grade and across classes. So it means that in PISA, if you want to measure the OTL, it will be quite tedious to ask the teacher to answer the questionnaire because maybe for the 35, 15 years old that are assessed in a PISA school, then you might have 10 or 15 teachers of mathematics, of science, or of reading literacy. So that's the reason why in PISA, there is up to now no teacher questionnaire. You have a student questionnaire, you have a school questionnaire that is filled in by the school principal. Since 2009, you have a parent questionnaire, but you don't have any teacher questionnaire. So it's not surprising that up to in 2000, 2003, and 2006, there were no measure of OTL, opportunity to learn, in PISA. But in 2009 and in 2012, some questions were added to the student questionnaire or to the test to measure the opportunity to learn in PISA. And I will start with the example of PISA 2012. In the student questionnaire, you can have this question: thinking about mathematical concept, how familiar are you with the following terms? Exponential function, divisor, quadratic function, proper number, linear equation, vector, complex number, rational number, radicals, subjective scaling. What is subjective scaling? Polygon, declarative fraction, congruent figure, cosinus, arithmetic means, probability. In fact, in this list of topics, there are 3 fake topics. Okay? And these 3 fake topics are designed to detect the student who stupidly answer the questionnaire, to detect the student who do not honestly respond to the questionnaire, or just tick, 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 without reading the statement, right? So, if you use the PISA 2012 data, this OTL data, what can you see? Here, I'm using Belgium data because I'm from Belgium. I decided to use Polish data because I'm here. And then I just say, well, let's take the neighbor country because you might be interested by the neighbor country, right? We are not interested by Australia or by United States, by Canada. So let's keep simple. Let's keep the table small enough so that you can read the table and so on. So I use the data from the 6th country. I did standardize the weight so that each country will contribute equally to my results. And the first thing I did was to compute a Cronbach alpha. The Cronbach alpha is an internal consistency index that ranges from 0 to 1. If it's close to 1, it means that my measure is unidimensional. And if it goes down to 0, it means that my measure is not unidimensional. So you can see that here, my Cronbach alpha is equal to 0.81. And usually, for questionnaire background, we considered we can use the data if the Cronbach alpha is larger, higher than 0.70. So here, we can say that I have a unidimensional measure. And you can see that here, this is the correlation between each item and the total. And you can see that for the 3 fake topics, I still have positive correlation. So it means that quite a substantial number of students tick these columns, and some students simply tick all these columns. But you can see that here you have also the Cronbach alpha within each country. So you have a unidimensional scale at the international level as well as within each country. Now, if you compute the correlation between this OTL measure and the student performance in mathematics, you can see that if I take all items, the 3 fake items included, I get a correlation of 0.52 in Belgium, 0.42 in the Czech Republic, 0.46 in Germany, 38 in Lithuania, 37 in Poland, and 46 in the Slovak Republic. Now I compute the correlation only on the true topic, and you can see that I increase my correlation. You can see that with the fake 3 items, I have a slight negative correlation. So usually it means that lower achievers are more inclined to say that they learn the fake topic, but this correlation is not that high. And if I compute the correlation of the true item and the control of the fake item, you can see that I have high correlation, 0.66, 0.57, 65, 54, 53, and 61 at the student level. So it means that at the student level, I can achieve with the PISA 2009 data a high correlation between the measure of opportunity to learn and achievement. Now, let's move to PISA 2009. In PISA 2009, we did have 16 items that are supposed to measure opportunity to learn. During the last month, how often did you have to read the following type of text for school, in classroom or for homework? Information text about water or books, poetry, text that include diagram of map, fiction, newspaper report or magazine article, instruction or manual telling how to make or to do something, how a machine works, text that include table or graph, advertising material, advertising in magazine poster. Then, during the last month, how often did you have to do the following kind of tasks for school? Find information from a graph, diagram, or table. Explain the cause of event in the text. Explain the way characters behave in the text. Learn about the life of a writer. Explain the purpose of a text. Memorize a text by heart. Learn about the place of a text in the history of the literature. Describe the way the information in the table or graph is organized. Explain the connection between different parts of a text. Once again, if I standardize the weight, I'm using the data from these 6 countries, and at the international level, if I compute the Cronbach alpha, I get 0.82 as Cronbach alpha. So I can state that if I just add all these numbers, 1 for many times, 2 for 2 or 3 times, 3 for once, and 4 for not at all, then I end up with a unidimensional scale. And you can see that once again, the correlation between each item that take part to the scale and the total score are quite large correlation, 0.73, 36, and so on. So every item is contributing to one dimension. Now, if I compute the correlation between this index and performance at the student level, no correlation. So does it mean that my measure of OTL does not predict student performance in reading? I did run a factorial analysis. And not surprisingly, as we have a Cronbach alpha of 0.8182, it's not surprising that your first dimension, all items will be loading on the first dimension. Then, on the second dimension, you can see that you have quite positive and large loading, 0.48 for diagram, 0.56 for table, 0.45 for fine information, and 0.34 for described table. Then you have 0.61 for newspaper, 43 for manual, 63 for advertising. And then here you can see 0.29 learn about the writer, 0.49 memorize text, 0.33 learn history. So on the 4th dimension, it seems that items that require memorization appear on dimension number 4. And you can see that on dimension number 2 is mainly using non-continuous reading material. That's diagram and table. I did apply a Varimax orthogonal rotation, and this is the 4 factors I end up after rotation. The first one, 4 items are loading on the first factor. Explain behavior, explain cause, explain purpose, fiction. And obviously, these 4 items mainly deal with continuous material. That's literature, broadly speaking. You can see that the second factors consist of reading table, fine information, diagram, describe table. It mainly concerns non-continuous reading material. The third one, memorize text, learn about the writer, learn history, poetry, and usually poetry requires memorization, the poetry, and find information. That's this one, mainly concerned about memorization. And the 4th factors concern advertising, newspaper, read manual on how to use a machine. Now, if we are interested by the correlation between reading performance and unrotated factor and rotated factors, you can see that we have, for the first factors, the general dimension where all items load positively, there is no correlation between performance and the general dimension. Then you can see for unrotated dimension number 2 that consists of non-continuous material. Once again, for the country, you have no correlation with student performance. For factor number 3, which consists of manual advertising, you have a positive correlation. But in fact, don't forget that 1 is many times, 2 or 3 is 2 times, 3 is once, and not at all is 4. So in fact, this positive correlation would mean the more you study manual, the more you study advertising, the more you study or learn reading newspaper, the lower is your performance. And then you can see that for the unrotated factors, which is memorization, in some countries you have no correlation, and in the case of Poland, you have some positive correlation. Once again. Now, if you use the rotated factors, then the rotated factor, remember that the rotated one was the continuous material, explain cause, explain purpose, explain behavior, and fiction. Now you have a negative correlation that I must invert due to the skill. And therefore, the more you read fiction, the more the teacher asks you to explain the behavior, the cause, and the purpose, the higher will be the performance of the student. There is nearly no correlation with rotated factor number 2. There is some in some country with the memorization, and you can see that you have here quite positive correlation. So the more you read manual, the more you read advertising, the lower will be your performance. So this is quite surprising results, because if you have an opportunity to learn something, then your performance, if you are assessed on this topic, should be higher. So how can you explain that the more you learn a topic, the lower is your performance? If you learn something, you should expect a higher performance. If you download it, then you should expect lower performance. So this is a summary that I just already discussed. What I did after that was to compute for each country the correlation between each item and the reading performance. And you can see that for some item, like explain the behavior, in 33 out of the 34 OECD countries, I have a positive correlation between that item and the reading performance. And negative, because I have to invert, sorry. And you can see that read text manual, 34 countries, the more you use manual, the lower is your performance in every country. And you can see that it's also with advertising as well, and also with memorized text. So how can you explain that in 34 OECD countries, the correlation between reading manual and performance is negative, which means that the more you read manual, the lower is the performance? And in fact, my interpretation is that this is not an OTL. In fact, in which type of education are we working with manual on how to use a machine? In vocational school. And therefore, why an opportunity to learn should be, if I have the opportunity, my performance will be higher. In vocational school, I think we do this kind of thing because maybe students cannot do other things. And therefore, maybe this has another meaning than the other OTL. From an analytical point of view, once I will run multi-level analysis with using student performance as my dependent variable and independent variable included OTL, if I have 4 factors of OTL, it's quite uncomfortable. Further, some items correlate positively and some items correlate negatively. So it means that I have different meaning. And we have seen that factors 2 and factors 3 are unrelated to performance. So I decided to try it with an item multidimensional scaling. There is 2 types of multidimensional scaling. In PISA or in TIMSS, in TIMSS, we are assessing mathematics and science performance. In PISA, we are assessing literature, mathematics, and science. And when the data are scaled according to a multidimensional model, one item belongs to one dimension and only one dimension. So, reading item belongs to the reading latent variable, and science item depend on the latent science dimension. That's called between item multidimensional scaling, meaning that one item can only belong to one and only one dimension. Then there is another multidimensional scaling, which is called within item multidimensional scaling, which allowed an item to depend on more than one dimension. And you can see that here, item x1 depend on theta 1 and theta 2. So it means that the student performance that I will observe on item x1 depend on the latent dimension 1 and depend on the latent dimension number 2. And you can see that x6 depend only on theta 2. And one example that can be used to scale international cognitive test in PISA would be to take the mathematics item and on the first dimension all item load on the first dimension, and you separate multiple choice item and open-ended item, and therefore the second dimension can be considered as a mathematical communication dimension. And this is what I have done with my reading for school item. I have defined 3 dimensions. The first dimension consists of this item. And I have suppressed all items that are linked to the memorized dimension, because this memorized dimension, when we use M+ to check for invariance, then it was totally different in Asian country than it is in European country. Because in Asian country, usually students are requested to study to memorize more than in European country. So we decided, as we want to have invariance in our dimension, to suppress these items where we have some invariance. And we kept this 11th item, and my first dimension consists of all items, and my second dimension concerns the non-continuous material item, and the third dimension concerns the 4 items that load on my continuous material. So I use a multidimensional RT scaling model with an item, and it's a 3-dimensional, not a 2-dimensional. And I use conquest, and I draw plausible value. And I use as conditioning variable school dummies to retrieve the between school variance for each dimension. I use the reading performance. I use a number of books at home, gender, and social background. I use engagement in reading, control strategy, memorization, metasum, elaboration. And I use also ISCET orientation, that's vocational versus general education, and whether the student repeat or not a grade. First step is the international calibration to get the item parameters. And the second model, the second step is the population model with all these conditioning variables conducted country by country, because the population model has to be different within country, between country. And these are the correlations that I'm observing at the student level. So you can see with dimension number 1, I have here this correlation, and with dimension number 2 and dimension number 3, I have negative correlation. So for dimension number 1, we see the general dimension. The more the student has the opportunity to learn, the lower is the performance. So I consider D1 as a response bias dimension. And you can see that now with dimension number 2 for non-continuous, if I take Poland, I have a correlation of minus 0.40. And if I'm using continuous text, I have a correlation of minus 0.48 at the student level. And you can see that we have more or less the same correlation in your neighborhood country. If I compute the correlation at the school level, then you can see that the correlation increases. And in the case of Poland, I have minus 0.57 and minus 0.65. So let me come back here to this correlation. And you can see that this correlation was quite low. And then using a multidimensional within item scaling model, I end up to quite nice correlation, because I succeed separating the response bias with the real through OTL. So quickly, OTL can be measured and uncorrelated with student at school performance. And if you want to measure OTL, then you should find some way to control for the response bias that students simply tick without reading, all the time, never, or all the time, okay? And it seems that the within multidimensional scaling appear to be quite efficient in providing solution to separate the response bias with the real information. Do you have any question? Yes?
I'm not sure I understand it properly, but during the calculation of the last 2 correlations you showed us, you exclude the biased respondents?
Well, let's come back to, I didn't exclude response bias, right? if I scale the data according to this model, right? A student will get a high score on D1, okay? Let's suppose that 4 means many times. We will simplify, okay? And let's suppose that 1 means not at all, okay? What kind of response pattern can you expect so that the student gets a very high score on D1 or a very low score on D1 based on this? So a student who gets a student who answers for all item 4 will get a very high score on D1, and a very high and a student who answers 1 for all item will get a very low score on D1. Now, let's try to imagine what a student's response pattern may be to get a high score on D3 and to get a low score on D1. O4 or O1, that's it. No. If the student, right, get O4 or O1, he will get a high score on D1 and a low score on D1, but will get an average score on D3. So if a student from general education take the time to read the statements that are proposed in the student questionnaire and responds honestly to this question, in general education, in academic education, we don't learn how to use a machine. You agree with me? And therefore, a student who is in general education should answer 1 to this item. But in general education, we ask the student to read fiction, and we ask student to explain the behavior, explain the cause, explain the purpose. So he should answer 4, 4, 4, and 4. So a student from general education should get high score here and low score here. And therefore, by this means, I can separate the student who respond this honestly from the student who simply didn't read the statement and just stupidly answer 4, 4, 4, 4 or 1, 1, 1, 1, 1. Do you understand what I mean now? Yeah. And therefore, you can see that where the raw score or the factorial factors couldn't provide any substantial correlation, I end up with quite interesting correlation at the student level and at the school level. And a correlation of 0.5 at the student level is quite a high correlation. It's unusual to observe 0.50 of correlation at the student level, and here 0.60, it's quite a high correlation at the school level. Yes?
Should we expect similar correlation if we just simply exclude from the sample those students with very low variance on the response pattern? If someone has a low variance, just sticking in a column once, 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 and just excluding those students of the sample, and instead of doing the factorial model, just a normal model, that would be the way to excluding the response bias. Right?
Yeah, but if you...
Are you using the data, of
dimensions,
course,
you can have very low variance.
No, like
also
low variance on all 12 items.
Well, I don't like this solution because...
I just, I'm not telling this is just an alternative, but just to check the, to compare the results.
Well, if I plot 2 variables, right, and then I have a few dots here, and then I have a few dots here, and then I say, well, I will delete this one, I will delete this one. Hey, look, I have a correlation of 0.70. It's a bit cheating. So, yes.
Somehow you try to take into account that someone is just taking the answering the following questions without thinking what actually is going on in the question or something.
I think you might solve some problems. You create other problems. Okay. I will try, and I will see whether I can retrieve this kind of correlation. But for sure, okay, we have 11th item. So I can say, okay, right, if I have 11.4, I will delete the cases. What about 10.4 and 1.3? Should I delete it or not? Yes, okay, right. And what about 10-4, no, 9-4 and 2-3? Should I delete or not? Where do you put the cut point? What is the rationale for your cut point?
This is the arbitrary.
Okay, so here I simply don't take such decision and I use within item multidimensional scaling to solve my problem without deleting any cases. Only cases who didn't respond to any item are deleted from this analysis. That's it, which makes sense.
So did you continue the analysis with those information? Like, for example, exclude of or weight differently cases from dimension 1? Or it's the end of your analysis? It's only an example?
Right now, the analyses are not yet finalized because I still have to draw the plausible value and I have to create the population model for all the OECD countries, right? And it takes some time to prepare all this conditioning file and so on. And then after that, I will use multi-level regression analysis to use student background, school background, and see what OTL can bring after taking into account student background.
So did you decide how to treat those cases from D1, dimension 1, or not yet?
No. Each student gets a score of dimension number 1, on dimension number 2, and on dimension number 3.
Okay. Yeah, okay.
I'm not sure to understand your question.
No, I understand your response.
Okay, all right. So for any student, I get a score on D1, on D2, and on D3. It's not a cluster analysis.
Why we have only 3 dimensions, not 4? Because on this scheme you have.
First of all, if you are working with 4 OTL dimensions, then it's quite difficult to summarize and to see the impact of OTL, right? So first thing, I want to reduce the number of dimensions to be used so that I can have a high correlation between OTL and performance. Okay. That's the first question. The second reason, as I stated earlier, why we can have country invariance for this dimension and for this dimension. For this dimension that I excluded from the final analysis, the invariance analysis showed that from one country to another country, this dimension can have a different meaning. The importance of memorization depends on the educational system. In some educational systems, memorization is very important, like in Japan, in Korea, in China, in Shanghai, while in European countries, memorization is less and less important, especially in the language lecture.
How do you explain the high correlation between your factor D2 and the overall achievements, since the D2 factor contains mainly such factors as such items as reading tables, diagrams, and describing tables, so there is not much reading at all. And the correlation was quite high, even higher with the continuous text.
I think that we should not limit literacy to fiction. If you are literate, of course, you need to understand fiction, right? You need to read fiction and to understand fiction. But if you take a newspaper, if you go to internet, if you go to a station and you want to take a train, or if you want to identify the gate of your flight and the time of boarding, then you need to read a table. And I'm not surprised, because if here I go back, the correlation between we have a negative correlation between D1 and D2 and a negative correlation between D1 and D3. Okay? It makes sense. And you have quite a positive correlation between D2 and D3. So what does it mean? It means that in school where we do fiction, we also do non-continuous material. That's the reason. And I think that because literacy and especially if you take the PISA test, if you take the PISA test and just say, okay, right, there are some material of the PISA test which are continuous and there is some material which are non-continuous, if you take this score instead of the global combined literacy scale, then you should increase for the continuous text this correlation, and for the non-continuous, you should increase this correlation, because the PISA test consists of continuous and non-continuous text. And therefore, it's not surprising to have positive correlation here and to have positive correlation as well here, because the PISA test consists of continuous text and non-continuous text. But it's an interesting question. I should use the continuous score and the non-continuous score and to see the results here and here, to see whether I observe differences.
Don't you think that this obtained effect is in fact some kind of school effect, as you said, in schools where people read tables or also and continuous text. The schools differ from the schools where people read only the technical materials. So
it depends on the educational system. In some educational system like Germany, well, you have really separate school type. You have Gymnasium, Hauptschule, Realschule, and Gesamtschule, right? And it's totally different. In one school, you have one type of education. I don't know the Polish educational system, but in Belgium, we have some schools that only provide general education. We have some schools which only provide vocational education, and therefore you can consider that if you are using only these two types of school, OTL, opportunity to learn, is mainly a school factor and not a student factors. But we have also some schools that provide general education and vocational education, and therefore this is not a school factor, but this is a track factors. And the difference between, I would say, the correlation at the student level and the correlation at the school level is that when you compute the correlation at the school level, you get rid of the student noise when answering the OTL. That's the reason why you increase the OTL at the school level. Thank you for your attention.